Alright, and welcome to 7-3.5 Mixed Review 2. Okay, number 6 says this. Find the area of the circle in the non-triangular area given the radius of the circle is 10 inches and EF is equal to 8 inches. And the altitude of the triangle is 5.8 inches. Okay, so a couple things here. This is kind of an involved problem, but still fairly easy. So thing number 1, we are trying to find this area right here in the orange. And this is kind of a powerful concept, because here's what we're going to do. We're going to do the area of the circle minus the area of the triangle. Alright, so if we can find the area of the circle and we can subtract away the area of the triangle, we have the leftovers. Very powerful idea in mathematics. Okay, so let's just kind of fill in these things. We know that the area of a circle is pi r squared minus the area of a triangle is 1/2 the base times the height. Well, check it out. They actually tell us what the radius is. The radius is 10. So we can go ahead and say, you know what? Pi times 10 squared minus 1/2 times. Now when we look at this triangle, what is the base? Well, I see here the base, EF, they tell us it's 8, so we know the base. So times the base of 8, and then times the height. Well, guys, height is just another way of saying the altitude. So when they tell us that the altitude of the triangle is 5.8, we'll check it out. We actually have that, the height as well, 5.8. Now I will leave you to finish these mathematical operations on your own. So make sure you pay attention to your order of operations, PEMDAS, when simplifying this. Alright, let's move on. Alright, problem 7. The following triangle has been dilated about the point 3, -2 by a scale factor of 4 and then reflected across the y-axis. What are the coordinates of the triangle's image? Okay, so here's what we're going to do. I'm going to go ahead and walk y'all through this for point A, and if point A is not the answer, you'll have to repeat this process for points B. So let's just kind of label some things. Point A is, oh here we'll switch colors. Point A is the point that we are concerned with, and it's over here at -2, 2. Since it's the point that's being dilated, we'll label that x, y. I also have our point of dilation, which is 3, -2, which will be our h, k. And lastly, we know that our scale factor of 4, which is t, is that. Okay, now what formula do we want to use? Well, of course, we want to go ahead and use our formula, which is, let's see, h plus t parentheses x minus h close parentheses comma k plus t parentheses y minus k close parentheses. And if we plug all this in, we're going to get an image. However, you'll need to realize that that is not the final thing. So let's do this real quick. Let's plug everything in. Where I know my h value is 3 plus my t value is 4. We can see that right there. My x value is -2 minus, and my h value is still going to be 3, comma. My k value is -2 plus, my t value is 4, my y value is 2 minus, and my k value is -2. Now before we move on, let's see, 2 negatives make a positive. And from here we can go ahead and start simplifying. We can say, well, you know, we have 3 plus 4 times whatever's inside the parentheses. We have -2 plus 4 times whatever's inside the parentheses. And -2 minus 3 is -5. And 2 plus 2 is 4. Hey, that's easy. Okay, moving on. We now have 3 and then comma and -2 parentheses. And here in a different color, let's go ahead and use this nice red. What is 4 times -5? Well, that'll be -20. And what is 4 times 4? That will be 16. And lastly, when I go ahead and combine these, I have 3 minus 20, which is -17, comma, -2 plus 16, which is 14. And here is a prime. But remember, we're actually doing two transformations. We're also reflecting across the y-axis. So the rule for reflecting across the y-axis is that x, y will then become -x, y. And so if it's to find a double prime, we simply transform the sign of the x value. So our negative 17 becomes a positive 17, comma 14. Our y value stays the same. Now, if that's not the answer, you will have to repeat the process for b double prime and or c double prime. All right, let's move on. All right, problem 8. Find the length of mk when given. Now let's just start labeling these things. mj is 2x plus 4, and jk is 4, and lk is 8. So a couple things here. Thing number 1, we have a tangent, and thing number 2, we have a secant. By the way, we know it's a secant because the line touches 2 points on the circle and goes inside and outside of the circle. So what's our rule for when we have a tangent and a secant? Well, it's always going to be the tangent squared is equal to the outside secant times the whole secant. Okay, that's kind of our rule. Or put another way, we could say, well, LK squared is equal to KJ times KM. Okay, so let's plug in these things. We have 8 squared is equal to KJ is 4 times, and this one's the tricky thing. A lot of students really mess this up. MK is 2x plus 4 plus 4. We have to combine this. We have to add those. Let's just kind of write it like this. 2x plus 4 plus 4 is really 2x plus 8 once we combine our like terms. So we can go ahead and let's just use a different color here. 2x plus 8. Now from here, y'all can go ahead and solve for x. The last thing I would say is we're searching for the length of mk. So whatever x equals, let's say that's a question mark. Well, mk is this whole thing which we just found was 2x plus 8. So I can say, 2x plus 8, whatever x is, we'll plug that in to find the length of mk. All right, let's move on to the next. All right, number 9, find the area of the shaded region below. Okay, well this one's a pretty simple problem. We're simply going to use subtraction again. All right, we're going to say, what, out here we have this gigantic rectangle, so we'll take the area of a rectangle minus the area of this triangle that we're getting rid of. So what's the area of a rectangle? It is base times height minus 1/2 times the base and height of the triangle. Okay, and I'm simply going to do some labeling. Let's call this base 1 and base 2, and the height really stays the same. Notice that this height, this is h 10.1, will also be this height right here. It will still be 10.1. I will leave y'all to plug in all the information and finish this problem on your own. Okay, problem number 10. Find the area of the regular polygon below. Well, if you will recall, what we want to do is simply break this up into its triangles first. And notice that it's a hexagon, so going all the way around we have 360 degrees in the central angles. Well, if we do 360 divided by 6, that gives us 60. So we can say, this whole central angle right here is 60 degrees. Now, while they drew the apothem right here, I'm going to draw the apothem right here, so this right triangle is pretty easy to see. Okay, and let's see, what are we given here? We're given that our apothem is a length of 10. Okay, so this one is a little bit of a trickier problem. Also, what do we know about the apothem? It cuts things in half. So 60 divided by 2 will give us 30. And this now gives us enough information to draw our right triangle. Now in this case, we know the apothem is 10. We know our angle right here is 30. And we want to know that length right there. Okay, and why do we want to know that? Well, the area of a regular polygon is equal to 1/2 the apothem times the perimeter. And in this case, we know that the area of our regular polygon is 1/2 times 10, because remember that's our apothem, times whatever the perimeter is. And so what I'm going to help y'all do is I'm going to help y'all set up a trigonometric function. So let's see. If we were to take this right triangle and label, there's our hypotenuse. We circle our relevant angles, so there's our adjacent. And here is our, here is our opposite. And so since we don't really care about the hypotenuse, since we care about finding the opposite and we have the adjacent, we are going to use the tangent function. We can say tangent theta is equal to the opposite, let's call the opposite x, is equal to the opposite over the adjacent. So here's what I'll do. I'll fill this in for y'all. The tangent of 30 degrees is equal to x over 10, and I'm going to stop right there. Whenever you solve for x, whatever x is, that is going to be this little bitty half segment. That's going to be that little bitty half segment. So ask yourself this question before you fill in the perimeter. How many little half segments will it take for you to find the perimeter? Alright, I'll leave y'all to puzzle that on your own, and I will see you guys in our next lesson.